In this video, I'm presenting the quadratic formula to solve quadratic equations, and I'm showing some examples of how to apply it. If we have a quadratic equation of the form ax squared plus bx plus c, where a is different from 0 and a, b, and c are real numbers, then we can find its solutions by applying the formula I wrote here. We need x to be the result of applying this. You should remember that the a quadratic equation can have 0, 1, or 2 solutions, and this is contemplated over here because if you look over here, we have a plus minus sign, which means that we can either find a solution by writing plus or we can find a solution by writing minus. And also there is a square root over here. I'll write it again here. It says square root of b squared minus 4ac. So the case of no solutions is contemplated here because the result of applying b squared minus 4ac could be a negative number, and then we won't be able to find the square root, and then we'll get the result of no solution. So let's see how this works. Let's look at an example. Suppose we are trying to solve 3x squared plus 7x plus 2 is equal to 0. First of all, we are going to identify what are the values a, b, and c in this case. A is the leading coefficient, is the coefficient that is multiplying x squared. In this case over here we have that a is equal to 3. B is multiplying x, so in this case is 7. And c is not multiplying anything, is the independent term. It's a number that is alone, so this is 2 over here. Now we want to apply the formula, so let's write it again. We want to say that x is, I'm following the formula that's written over here. We have negative b, then we have plus or minus, that means we have two options. Then we have the square root of b squared minus 4ac. And we have all of that divided by 2 times a, 2a. So in my case, we have minus, and then b is 7, so we have here negative 7. And then we have plus or minus, and the square root. We have 7 squared minus 4 times a, which is 3, times c, which is 2. And then we have all of these divided by 2 times a, so 2 times 3. So what do we have here? We have negative 7, then we have this plus minus and square root. We have 7 squared, which is 49, and then minus, and then we need to multiply 4 times 3 times 2. So 4 times 3, that's 12, times 2, that's 24. So inside the square root, we have 49 minus 24. All of this is divided by 2 times 3, so it's divided by 6. So we have negative 7 plus or minus inside the square root. 49 minus 24, that's 25, so we have square root of 25. And then all of these divided by 6. One more step, because we can find what is the square root of 25. So we have minus 7 plus minus 5 divided by 6. So the plus minus is saying that we have two options. One option is going to be negative 7 plus 5 all divided by 6. And the other option is going to be negative 7 minus 5 all divided by 6. In the first case, we have negative 7 plus 5, so that's negative 2 divided by 6. So that gives us the answer minus 1/3, negative 1/3. In the other case, we have negative 7 minus 5, so that's negative 12 divided by 6. So that's negative 2. So we got two possible values for x, negative 1/3 and negative 2. And we want to actually check that those values are solutions for the original equation. Let's begin with the value negative 2. So we have 3 times the square of x, So negative 2 squared plus 7 times negative 2 plus 2. And we want to check if the result of this is actually 0. Well, this is saying that we have 3 times, and then we have negative 2 squared, so 4. And then we have 7 times negative 2, that's negative 14, plus 2. So this is 12, minus 14 plus 2, which is actually 0. So it was correct. That's a solution. We already checked. Now we have to repeat the same with negative a third. And let me write it in 1 second here. Let's see if this is true. We are here checking if the solutions we found are actually correct. So we have 3 multiplying, and then we have negative a third squared, so that's 1 over 9. Minus, we have 7 multiplying negative 1/3, so that's minus 7 over 3, plus 2. And this is, we can cancel here 1 factor of 3 from the denominator, so we have a third, minus 7/3, and then instead of writing 2, I'm going to write 6 over 3, so we have common factor 3. So we have 1 minus 7 plus 6, all of that over 3, and that's equal to 0. So we verify that the second solution, it's also a solution.